Hey there, welcome to another video on math problem solving. This is Bharat Devyan from Zhuang Academy, and in today's problem we're going to be doing what officially in math is called series and sequences, right? And in fact it's about finding the sum of these series. For a moment, even though you see 5 problems here, let's zero in on this guy, right? So what is half plus 1 by 6 plus 1 by 12, on and on and on till 1 by 10,000 and 100. Now, the reason why I want to kind of look at problems of this nature is to show you how process methodology, algorithms, and just smarter way of approaching math can make such a huge difference, right? Because the brute force method here would be to kind of take half, think of it as 0.5, take 1/6 and then find the decimal form for 1/6, 1/12, so on and so forth, and then you keep adding one after the other. And it will take you forever to get to the answer, but you will definitely get at the answer. And it won't be an accurate answer because you'll be dealing with a lot of irrational numbers in between. And you'll have to deal with all of that, be able to do some kind of approximation, and you would get to an answer which might not be the ideal one, but you would definitely get it. This is the brute force method, and this will help no matter what. But as you can see, you even to figure out how many such numbers are going to be there, you will still need to do the math, right? How do you know you're going to stop at that? And in fact, the fact that after 1 by 12, what comes next also requires you to think in terms of math, numbers, and patterns, which is the real lesson of today's class, which is to think about how patterns and numbers and the very fundamental element of how this is weaved into math plays a big role in terms of everyday problems that we face in math. Now, in this case, the whole idea is to figure out a pattern. So I want you to pause the video here, think about this problem, and first try to predict what's going to come next. So you have half, you have 1 by 6, you have 1 by 12. What's going to come next? What is the next number that you're going to see? And is there a pattern to this particular idea? Like, is there something that's going to take you there and which will allow you to figure out what's next? And this video is all about learning how to think about these patterns and think about these sequences and uncover this before you can actually try to solve them. All right, welcome back, and I hope you gave it a good shot in terms of thinking about what comes next and what the pattern of this particular sequence is. If not, let's try and figure this out. Now, one way to think about this is, the numerator for all of them is 1, so that doesn't change. What changes is the denominator, right? And remember my definition of intelligence, knowing difference between similarities and similarities between differences. So the denominator is different, and you need to figure out what is the similarity between all these different denominators, because there is a similarity, and that's what we call as patterns. So let's write that down. So I have 2, 6, 12. What comes next? So I can think of a difference being 4, 6. So maybe the difference to the next one should be 8, therefore 20, and the next one should be 30. Sounds very, very plausible. This could totally work out. But I also want to think about it, how do I arrive at this? How do I find a formula to arrive at 20, 30, and 42 after that, right? So for that, what I need to do is think of this entire sequence in terms of a place and a value, or a position and a value. So the very first number is 2. The very second number is 6. The very third number is 12. And by extension, what we calculated was the fourth number is 20. The fifth number is 30. And it keeps going. So I need to connect this using a formula so that I can find the nth position. Right? Position might be a better way. A position against value. The nth position, what is that going to be, and is it possible to connect it in terms of n itself so that all you need is an input of n and you can get the value here? So if I give 5, I should be able to get 30. If I give 4, I should be able to get 20. That's my idea, right? So one way to do that is to actually factorize your numbers, right? So 6 is nothing but 2 times 3. 12 is nothing but 3 times 4. 20 is nothing but 4 times 5, and you already see a pattern here because the same 2, 3, 4 is what you see here as well, and you see a number beyond that. So in other words, all I have to do is take any number, for example the 7th number, I can say 7 followed by multiplying the number that follows 7. So 7 times 8, which is 56, would be my next number, which is true because here the difference was 12. The next difference has to be 14, making this 56. Okay, so if I have the value for n, it will basically be n into n plus 1. Okay, now what we can do is to write down this entire sequence, which is 1 by 2 is nothing but 1 into 1 by 2, plus 1 by 6 is nothing but 1 into 2 by 3, plus 1 by the next number here is 12, which is 1 divided by 3 times 4. And as you can go all the way till the end, you'll realize that the last number, which is 10,100, is nothing but 100 into 101. Okay, so there you go. So this is your entire thing. Now, how do you sum this up? Now you've figured out the pattern. Pattern has really helped you. Math has really helped you arrive at the pattern. But what can you do with this? So one is to investigate this particular guy, right? So you have 1 divided by 3 times 4. Is this possible that I could write it as some sum or difference of just a fraction that is 1 by 3 and 1 by 4? Because remember, when you find LCM, you just need to multiply the denominators together. And a little bit of trial and error would help you get to the value that is 1 by 3 minus 1 by 4. Because when you cross multiply, it's 4 minus 3, the numerator becomes 1 and the denominator is 3 times 4, which is 12. So now you can rewrite each and every one of them as, okay, this is 1 minus half plus half minus 1 by 3 plus 1 by 3 minus 1 by 4, so on and so forth, all the way till 1 by 100 minus 1 by 101. Okay, now all you need to do is to recombine these values. So if you recombine it, you realize that the minus half and the plus half cancels, minus 1 by 3 and plus 1 by 3 cancels. It keeps on going all the way till 1 by 100 getting cancelled. The only thing that doesn't get cancelled is minus 101. So the very first number and the very last number of the split series is going to be left out. So 1 minus 1 divided by 101, which is 100 by 101, is going to be the answer, which is way more simpler than the brute force method of actually adding half plus 1 by 6 plus 1 by 12 using probably a calculator, Excel sheet, or a computer. Okay, please apply the same thing to all the other series that I've given here and see if you can get the answer. And please leave your comments whether you're able to at least find the pattern in each one of them. And I'll see you in the next video. I hope you like this video and enjoy it. Thank you so much.